Welcome to my video lecture based on electrical machine 2. Paper code PCE 501. Today's lecture is based on Hunting of Synchronous Machine. In my previous lecture, we have discussed about synchronous machine and its operation, parallel operation, various testing, and power equations, characteristics, and many more things we have discussed in previous lectures of synchronous machine. So today we will finish our lecture related to synchronous machine, and it is last lecture of synchronous machine. Myself, Poonam Banerjee, Assistant Professor of Electrical Engineering Department, Dr. Sudhir Chandrashur Institute of Technology and Sports Complex. Previously it was known as Dr. Sudhir Chandrashur Degree Engineering College, and this institute is under GISP. So we will continue about hunting of synchronous machine. Hunting of synchronous machine. Hunting is basically a phenomenon where synchronous machine starts oscillations, and that phenomenon is known as hunting. Now, how the hunting is going on and what are the physical reasons of hunting and what is the cause and what are the effects, how we can minimize this effect of hunting, that thing we will discuss in this lecture. So, let us continue with our topic, that is hunting of synchronous machine. It's a very interesting topic. Let us start with. The phenomenon of oscillations inverted to its new equilibrium position in synchronous machine. When sudden changes of load occurs, then synchronous machine wants to get new equilibrium position, and that is known as hunting. That means hunting is a phenomenon where synchronous machine rotor start oscillating and try to get its new equilibrium position. And this situation occurs when sudden changes in load and the machine will try to hunt the new equilibrium position. So that phenomenon is basically hunting phenomenon. So now we will see that one reason we have find, that is sudden changing in load. Now we will find the other reasons and how it can be minimized and what are the effects, what will happen if hunting occurs, then that we will see. Effects of hunting in synchronous motor. Synchronous motor hunting effect can be described in two conditions. One is at loaded condition, when the machine is loaded, and another one is when the machine is not loaded or no load condition. So, first we will talk about no load condition. At no load, stator pole axis and rotor pole axis almost coincide with each other. We can understand that at no load, stator pole and rotor pole, they are just coincide with each other. And at loaded condition, rotor falls back its axis with respect to the stator pole axis, and the angle between. Now, at a loaded condition, the rotor falls back its axis and with respect to the stator pole axis, and the angle by which it falls back is known as load angle. That means the angle between the rotor with its axis with respect to the stator pole axis, and the angle by which it falls back is known as load angle. So, now if the load connected with the synchronous motor suddenly changes with the large load, the rotor tries to achieve its new equilibrium position that rotor hunts for new equilibrium position and starts hunting. But due to inertia of rotor is unable to achieve its new equilibrium position instantaneously. Now, while achieving new equilibrium position, rotor passes its equilibrium position, then it produces more torque which will decrease the load angle. Again, rotor oscillates in opposite direction. So what will happen? If the load connected with the synchronous motor suddenly changes with large load, the rotor tries to achieve its new equilibrium position. That rotor hunts for a new equilibrium position and starts hunting. But due to inertia of rotor is unable to achieve its new equilibrium position instantaneously. Now, while achieving new equilibrium position, rotor passes its equilibrium position, then it produces more torque which will decrease the load angle. Again, rotor oscillates in opposite direction. So here something is point to be highlighted, that synchronous motor sudden changes with large load, then the rotor will try to achieve its new equilibrium position. So let us think that when sudden changes in load occurs, definitely the rotor will first feel the effect of load changing. So definitely the rotor will start oscillating and definitely it's try to achieve its equilibrium position. So the hunting will occur in rotor side. But due to the inertia of rotor is unable to achieve its new equilibrium position. This is another important part. Due to the inertia of rotor is unable to achieve its new equilibrium position instantaneously. Now, while achieving new equilibrium position, rotor passes its equilibrium position, then it produces more torque which will decrease the load angle. Again, the rotor oscillates in the opposite direction. That means when the rotor will try to get the new equilibrium position, it will need more torque to achieve the equilibrium position and decrease the load angle. So again, to doing this, again the rotor will start oscillating in opposite direction. Okay. So now the load torque should be equal to electromagnetic torque, and the torque angle is also mentioned constant at condition rotor becoming equilibrium position or steady state position. So it will be K d omega m dt plus tau L equals to tau E. That means load torque should be equal to electromagnetic torque, and if this condition persists, then the rotor will be at equilibrium position. But due to the sudden changes in load, it will be not equal part. That means TL is not equal to T. So we have added a term. It is resulting torque which changes the speed of the motor. d omega m dt. This is the part of resulting torque which changes the speed of the motor. So J is the moment of inertia, omega m is the angular velocity of the rotor in mechanical unit. So it is resulting torque which changes the speed of the motor. Okay. So it will cause, what is the causes behind it? First of all, sudden changes in load. Secondly, fault occurring in system. with generator supplies. Thirdly, sudden changes in the field current. Fourthly, cyclic variation of the load torque. These are the four conditions or four causes for creation of hunting. So first of all, sudden changes is load. Second, fault occurring in the system with generator supplies. Third, sudden changes in the field current. Fourth, cyclic variation of the load torque. Any of the four causes will create the hunting in rotor. So, whatever may be the situation, the rotor will start oscillation and it will create the hunting phenomenon. Okay. So, any of these causes can be the reason for creating hunting in synchronous machine. Okay. So, this is the expression where we have shown that the j d omega dt, this part is added with our load torque, and this is the resulting torque which changes the speed of the motor. And when TL equals to becomes to T, then the machine will be reaches its equilibrium position. Now we will discuss about the effect. What are the effects of hunting? What will happen if hunting occurs? Definitely we can understand synchronous machine is a very larger device, and if the rotary start vibration, then definitely there will be some disbalance occurring, and that will be not a small disbalance. That will be a huge disbalance occurring. So we will see what are the effects. First of all, it can lead to loss of the synchronism. First effect, it can lead to loss of synchronism. Secondly, it can cause variations of the supply voltage, producing undesirable lamp flicker. So what will happen? It can lead to loss of synchronism. Secondly, it can cause variations of the supply voltage, producing undesirable lamp flicker. Thirdly, increased possibility of resonance. Fourthly, large mechanical stress may be developed in rotor shaft. Fifthly, machine loss and temperature increase. So that means what will affect? First, it will lose its synchronism. So when the machine will lose its synchronism, definitely what will happen? How we can know that machine is lost its synchronism? Definitely there will be changes in the dark and bright lamp method, which will prove the machine is synchronized or not. So lamp flicker will occur, or synchroscope will start oscillating, and it will show that machine is not in synchronism. So if suddenly machine lost its synchronism, that we have to understand that hunting is occurred. Due to that, machine lost its synchronism. Thirdly, increased possibility of resonance. Okay. And fourthly, large mechanical stress may be developed in rotor shaft. Definitely, if rotor starts oscillating and it try to achieve new equilibrium, so more torque is produced. So definitely mechanical stress will occur in the rotor shaft. And if the mechanical stress will occur, definitely machine will get much more loss and temperature will increase, because we know that whatever maybe the loss occurs, it will affect in rise in temperature. So definitely the temperature of the machine will rise. And how we can reduce the effect of hunting? Hunting occurred, but if we are unable to control it, then it will damage the machine. Machine will lose its synchronism, mechanical stress will increase, temperature rise will increase, and our total system will be disbalanced. So that phenomenon will not continue for many times. So definitely we have to think about the reduction of hunting method, that how we can reduce that hunting phenomena. So for reducing it, we have to use, first of all, damper winding. Okay. And secondly, flywheel. Prime mover is provided with a large and heavy flywheel, and this will increase the inertia of prime mover and help in maintaining the rotor speed constant. Okay, that means damper winding will be built inside the rotor side to reduce the hunting effect, and also it will help the motor to start starting phenomenon. It will also help by the motor by using damper winding. And another aspect is flywheel. Okay, flywheel will be connected with the prime mover, and this will increase the inertia of the prime mover. And as the inertia will increase, why the inertia increase? Because the flywheel is very large and heavy. If in the prime mover a large flywheel is connected, which is very heavy and large, so definitely the inertia of the prime mover will automatically increase, and that will help in maintaining the rotor speed constant. So the reduction of hunting phenomenon can be done by these two methods, that is damper winding, and another one is using of large flywheel. Now I will discuss some points also. That is, sometimes an alternator will not operate satisfactorily with others due to hunting. If the driving torque applied to an alternator is pulsating, such as that produced by diesel engine, the alternator rotor may be pulled periodically ahead of or behind its normal position as it rotates. This oscillating action is called hunting. Hunting causes the alternator to shift loads from one to another. In some cases, this oscillation of power becomes cumulative and violent, and enough to cause the alternator to pull out of synchronicity. In salient pull machines, hunting is reduced by providing damper winding. It consists of short-circuited copper bars embedded in the pole faces. When hunting occurs, there is shifting of armature flux across the pole faces, and thereby including currents in the damper winding. Since any induced current opposes the action that produces it, the hunting action is opposed by the flow of induced current. The following points to be noted, definitely you have to remember, that hunting generally occurs in alternator driven by engines because the driving torque of engine is not uniform. Secondly, alternator driven by steam turbines generally do not have a tendency to hunt, since the torque does not pulsate. That means steam turbine driven alternators are generally not hunting because of the torque production. Thirdly, in cylindrical rotor machine, the damper windings are generally not used, and it is because of solid rotor provides considerable damping. And under damping condition, under normal running condition, damper winding does not carry any current because rotor runs at synchronous speed. So these are the things we need to remember. And up to that is for today's class. We have completed synchronous machine chapter briefly, and this is our last topic, that is on hunting. From our next lecture, we will start with our new module, that is on three-phase induction motor. This lecture I have covered mainly from the book of Ashfaq Hussain. You can go through that book, and you can also prefer the book of V.K. Mehta of electrical machines. So thank you all. Thank you all for listening my lecture.